So welcome guys to Metabolism Wallah NEET Inorganic Chemistry Tricks. Find out electronic configuration of any element. Here I will tell you the trick. Find out the electronic configuration of elements in the D and F block 2. So watch till. This will be helpful in the IE, EG, EN. There is ionization energy, electron gain enthalpy and electronegativity. Helpful to find out which element show what oxidation state and helpful to score marks in NEET JEE or that CUE. Things to be known beforehand. Full periodic table memorized. I have a video on my channel. You can go and watch there. Knowledge of noble gas, which I have given to you in my previous video. Knowledge of number of elements in each block I have given you in my previous video. Afbau Rule, Afbau principle I will teach you in this video. Okay, let's start with the Afbau rules. Afbau rule or Afbau principle states that how the orbitals are filled up by electrons one by one. So we know S orbital contains 2 electron atoms, P orbital contains 6 electron atoms, D contains 10, F contains 14. Now electrons are filled up in this order in non-hydrogen species. Non-hydrogen species. In hydrogen species, the electron directly move from 1s to 2s to 2p like that. But it is in non-hydrogen species. In non-hydrogen species, the order is like this: 1s, 2s, 2p, then 3s, then 3p, then 4s, then 3d. 4s orbital will be filled first, and then 3d, then 4p, then 5s, then 4d, then 5p. Then 6s, then 4f, then 5d, then 6p, and then 7s, and then 5f, and the series continue like this. Okay, so I will consider that you have understood the Afbau rule. If you haven't understood the Afbau rule, go consult some expert. There are several videos on the YouTube on the Afbau rule. Go check them and then return to my channel. Okay, and I will consider that you can apply this into higher elements also, like tin and lead. Here the filling is in this way. Okay, you understood this from this. Now, so-called exceptions. There are no exceptions in arrangement of electron in S and P block. Okay, in S and P block there is no exception, but discrepancy arise in D and F block. Those are also not exception, but I will give the genuine reason for them. Okay, let's start. In 3D series, the rule is like 3D orbital is more stable with 5 electrons and 10 electrons. They would not tolerate 4 electron or 9 electron. Okay, when there is 4 electron or 9 electron in 3D, then an electron is transferred from S orbital to D orbital. Okay, now to start with 3D series, you have to make a chart like this, and so pause the video and make a chart like this in your copy, and then write S here and D here. Completely fill up the S orbital and then start filling up the D orbital. So here you can see that D orbital contains 4 electron, and here you can see D orbital contains 9 electron. So we will transfer one electron from S orbital to D orbital. Look at this. Done. 3D series done. In 4D series, you have to memorize this. First 2 elements contains 2 electron in S orbital. First 2 element contain 2 electron in S orbital. Repeat with me. First 2 element contain 2 electron in S orbital, and then the last element contain 2 electron in S orbital. This is because of stability reason, we all know. And then 4D orbital with 10 electron is very stable. So if possible, both the S electron can move into the D orbital, making the S orbital completely empty. Okay, in simple words, if there are 9 electron in D orbit, when there is 1 electron in S, the 1 electron is also transferred to the D orbit to gain extra stability. Okay, now write the 4D series like this. I told you, first 2 elements 2 electron, and then the last element 2 electron in S orbital, and rest all 1 1, and then fill up the d orbital, like not 1 2 3 4 but 1 2 4 5 6 in this way, because here would be 3, then here would be 2. So we are transferring 1 electron from this s orbital to the d orbital. So if we transfer this, then there will be 1 electron in s orbital and 4 electron in d orbital. Okay, understood? Now we know that d orbital with 10 electron is very stable. So we can transfer this 1 electron to the d orbital and get a configuration like this. So our final result will be like this. Plus we are done with the 4D series. Now 5D and 6D series, there is one shot. The configuration of 5 electron is not so much stable. So electron do not prefer to move from s orbital. If the 5 electron species is possible in 5D or 6D orbitals, due to their large size, the s electrons from s orbital do not prefer to move. But discrepancy arises in second and third last element in 5D, second last element in 6D. So second and third last element in 5D and second last element in 6D. There the s orbital contain only 1 electron and the other electron moves into the d orbital. Okay, so make your charts like this, then fill up the s with 2 electrons each, and then fill up the d. Now remove 1 electron from s orbital, second and third last s orbital in 5D and second last orbital in 6D, and then add 1 electron in the d orbital here also, and boom, we are done. Now in F block, you can notice here that D1 configuration is present the first element and the unstable element. Here the first element is not La but it is Ce. La is a D block element and Ce is a F block element. Cerium is a F block element. Lanthanum is a D block element. First element and the unstable element, in which D7 and D14 configuration can be made like this, because F orbital cannot contain more than 14 electrons here and here, okay, and here, and this is D block. So last electron will obviously enter in 5D series. Okay. Make your chart like this: SDF. Now fill up the s orbital with 2 to 2 to each, d orbital with 1 here, 1 here, and fill up 0 here fully. Okay, and then f orbital with 0 in this one, because it is d block element and all these are f block element, and fill up the f orbital in this order. We know that 8 electron in f orbital is unstable, because the f orbital will be very happy if it have 7 electron or 14 electron, right? Will be stable if it have 7 electron or 14 electron. This is because of exchange energy. Okay, I will tell you all this in the atomic structure. Okay, so we will transfer 1 electron from here to here, and F block and F orbital will not tolerate more than 14 electrons. So we will transfer 1 electron from here to here. Okay, look at this. We have transferred this one and we have transferred this one. Okay, now the final product is this one. Done. Wait, where are you going? The ACTNIDE series is waiting for you. So in the ACTNIDE series, we can see the first F electron enters in second element. The second element is protactinium. Okay, first F electron enters here, not here, but it is an F block element. Actinium is a D block element, but thorium is an F block element. But here the last electron enters in the D orbital, but in protactinium the electron enters normally into the F orbital. And then the next three, that is second, third and fourth elements have D1 configuration, and the unstable ones also have D1 configuration here and here. Okay, this is our rule. So make your chart, then start filling 7s orbital with 2 electron each. It will be constant. And then D orbital with 1 electron, then 2 electron. We have seen 2 electron here, 1 electron, 2 electron, then 1 1 1, 1 2 1 1 1, then all 0. Then fill in the F orbital in this way, and then transfer 1 electron from here to here and 1 electron from here to here. Okay, so our F block actinide series is also done. Thanks for watching. You are the best. Next video will be on ionization energy, electron gain enthalpy and electronegativity. Thanks.